Hello my dear students, I welcome you all for SVK tutorials. In this video, I am going to discuss the model question paper pattern for the 5th semester subject called Mathematics for Machine Learning with subject code 18 AI56. This question paper is only for the branch Artificial Intelligence. Now moving on to module 1, we have a questions on vector spaces. So on that vector spaces, we require to find the linear combinations of the given polynomial. Then we have a problems on finding the distance between for the given two vectors called u and v, finding the angle between the two vectors u and v, finding the projections of u onto v. Also, we have a problem on consistency, which has for the given system of equation you require to find no solution, unique solution, more than one solution, and also find the solution when lambda equal to 2 and mu equal to 8. So we have an options for with this question, define inner product spaces and problem on inner product spaces. Find the dimension and basis of general solution W of the following homogeneous system of equations. Moving on to next question. Determine whether or not W is a subspace of R3. Suppose the vectors u, v, w are linearly independent. Show that the vectors u plus v, u minus v, u minus 2v plus w are also linearly independent. So if we have the choice between 1 and 2, you can choose the question number 1 for your examination and answer the question number 1 as it is easy to answer, since the given problem is on vector space and finding the linear combination of that, and also the next problem is on finding the distance between two vectors, angle between two vectors, projection of one vector onto another vector, then consistency problem. So you can easily score 20 out of 20 out of these three questions. Moving on to module 2. So let W be the subspace of R4 orthogonal, the problem on orthogonal basis and orthonormal basis. Question number B is on find a basis for the orthogonal component. Question number C is on given three vectors. We require to show that the given vectors are orthogonal and basis. Find the coordinates of an arbitrary vector V relative to the basis S. Moving on to optional problems. The question number 4a is being given on eigenvalues and eigenvectors. You require to find the eigenvalues and eigenvectors for the given matrix A. Question number 4b is on for the given matrix P, you require to find the diagonal form. You require to deduce the matrix to diagonal form. Next, find the singular value decomposition, which is standardly called as SVD problem. So, as a teacher, I am suggesting you to choose the question number 4, since it is easy to answer. We have three standard problems there. One is on eigenvalues and eigenvectors, another is on diagonal form, and finally we have an SVD problem called as singular value decomposition. If you answer these three questions, you are going to score 20 out of 20. Moving on to module 3. This module is on vector calculus. We have a standard problems here. Given u, v, w, you require to find grad u, grad v, grad w, and we require to show that these three are coplanar. Next, a particle moves along the curve for the given vector r. We require to find the magnitude of the tangential components of its acceleration at t equal to 2. Find the rate of change for the given function phi is equal to xyz in the direction normal to the surface at the point 1, 1, 1. Moving on to optional question here, 6th question. So find the values of constants lambda and mu which intersects orthogonally at the given point. Moving on to question number B, 6b. Define gradient of a vector valued function. Consider the given function h, f and g. If f is given, you require to compute the gradient of h with respect to t. You require to compute gradient of h with respect to t. Moving on to question number 6c. Define a Jacobian of a vector valued function. You require to define the Jacobian of a vector valued function. Then for the given function, we require to find the Jacobian of f at the with respect to the given point. So if you take an option, you can choose question number 5 and answer question number 5 fully, and you are going to get out of 40 here. Moving on to module 4. The module 4 is of probability and distribution. So there is a problem on standard problems on probability called they are going to provide P of A, P of B, P of A union B. So by using mutually exclusive events, we can solve the given problem. Unknowns called P of A intersection B, P of A intersection B complement, P of A complement union B complement. Given a density function problem, you can define whether the given function is a PDF or not, probability density function or not. Then they are asking to find if so, if it is a PDF, determine the probability determine the probability that the variant having this density will fall in the given interval or not. Also find cumulative means CDF, cumulative probability function of f of 2. And there is one more standard problem which is of probability. There will be a problem on using Bayes theorem or conditional theorems. Using all these things, we can have one more problem which is of question number 7C or 8C will be of this problem. Moving on to question number 8A. The problem is on binomial distribution. It is a standard problem. They have given a binomial distribution. And question number 8B is of on random variable. Given a set of values, you require to find the expectation of x, variance of x, expectation of 2x minus 3, variance of 2x minus 3. I told you, right, question number 8C will be of a standard problem. You can go through this problem. Module 5 is of optimization. Definitely one problem, one question will be on definitions in this module. Get ready for the definition and answer easily. Here they have been asked in question number 9A, what is the gradient descent? With the help of gradient descent, find the point at which the function f has optimal solution. Moving on to question number 9B, the problem is on constraint optimization. Using the concept of constraint optimization, you can solve this problem easily. Moving on to question number 9C, the problem is on extreme values. You can solve easily by using the concept of extreme values. The optional problem is 10th A is of define convex function. Determine whether the given function f of x is convex or not. Question number 10th B is on standard problem. Using a Lagrange multiplier, we require to find the dimension of the rectangular box open at the top of maximum capacity whose surface area is 432 square centimeter. And next problem is on standard derivation. Prove that a non-negative weighted sum of convex function is always a convex. So I preferably tell you to choose the question number 10. If you have an option of this question, you can choose the 10th one and answer easily. I wish you all the very best for your upcoming examination. So do well in your examination and all the best for your examination. Thank you all for watching this video. Those who are not subscribed to my YouTube channel, you can do subscribe to my YouTube channel.